Here's my quick video on how to redate the Peloponnesian War. Peloponnesian War has been misdated back to 431 BCE, but it originally occurred in 403 BCE, but that causes a little problem when that happens. One of the problems is the Delian problem. This is a math problem that came up where a plague broke out during the war, the first year of the war in 430 BCE, and they consulted Plato regarding this. This is a little reference to Plato being consulted in 430 BCE to try and stop this plague. If you want to stop the tape and read that in detail, you can, but there's a little problem here because Plato wasn't born until 428 BCE, so this is 3 years after the war broke out that he would have been born, and now he's being consulted, so something's wrong here. Oops. So what we want to do is, this means nothing. This is just an example of what happens when the timeline is revised. You get people being born before they die and all kinds of things, and suddenly people are now being consulted before they're born. So how can we fix this timeline? We're very fortunate because there is a solar eclipse occurring during the first year of the war, described by Thucydides, who was edited by Xenophon. So if we can find another eclipse, we can try and redate the war. We'll use a Delian problem first as a reference. We need Plato to be at least 20 years of age, of course, and so we're going to look for an eclipse after 404 BCE. The eclipse also must happen during the first year of the Olympic cycle, because that's part of the history of the Peloponnesian War. Thucydides described the eclipse specifically as a crescent and some stars coming out, and that kind of sounds like a total eclipse. Total eclipse is the ones where the stars come out. Annular eclipses don't, and the 402 BC eclipse is when that happens. NASA says that star visibility requires a very dark, cloud-free sky during totality to see stars. So we're just thinking that that's pointing to the 402 BC eclipse instead of the 431 BC eclipse, which was an annular eclipse. The annular eclipses do not create the same kind of darkness that a total eclipse does, because an annular eclipse does not cover the entire surface of the sun, as does a solar eclipse. So I'm going to show you two videos. The Redshift program does use the maximal phase of night to illustrate the 402 BC eclipse, but it does not use that for the 431 BC eclipse. It's kind of an unscientific way of doing it, but it shows you the differences in the intensity of these two eclipses. But first we're going to look at a map to show you generally how close to Athens these two eclipses would have been. You can kind of get a general idea of the central area of the eclipse. The arrows point to the midline of the eclipse. So you can see in the 402 eclipse it's much, much closer to Athens than the 431 eclipse, which occurs over Asia Minor, actually. So again, in the eclipses we're going to look for the different phases used by the Redshift program to show the night sky, simulated daytime sky rather, and it shows an extra intensity for the 402 BC eclipse that is not seen with and not used with the 431 BC eclipse, which suggests the degree of intensity is sufficient to warrant that extra degree of darkness. So here's the 431 BC eclipse occurring. Notice there's just going to be one change. There it is. Change back. Just one change of darkness for that eclipse that happened somewhat away from, there it is, from Athens. But in 402 BCE it uses two phases of night, using the maximum night phase, and that's what I wanted to demonstrate here. You can see two changes right quick. 1, 2, there it is. So in comparing these two eclipses and assuming that stars would have been seen, more stars, there you go, would have been seen in 402 BCE. So 402 is going to be a better eclipse match, obviously, than 431 and on that little aspect. Also, 402 BC matches another criteria because the war has to start in the first year of Olympic cycle, and 403 BCE is the first year. So it also resolves our Delian issue. Plato would have been 25 years old, plenty old enough to be consulted regarding a math problem. Much, much better than his not having been born yet, right? Of course, of course. So now we're going to look at how this timeline, beginning the Peloponnesian War in 403, matches our other revisions, our other adjustments that we have. It does match perfectly when we align 403, and that normally happens when you reestablish an original chronology. They always look better than the revised. 455 BCE is our dating for Cyrus, which we can confirm by the bat 4956 in the Bible, and we can coordinate that in connection with a cryptic reference by Herodotus for when the Battle of Marathon happened. You can stop and read this in detail, but basically it talks about there having been an account in which a man had given him a matter of a gigantic warrior with this huge beard at Marathon killing a guy next to him. Of course, the huge beard reference is a reference to Darius the First. It's necessary to place Darius in a cryptic manner to the Battle of Marathon, because when the chronology was revised, they added 30 years to the reign of Darius and were only able to compensate it by 26 years removed from the Neo-Babylonian kings. And so he survives himself in the revised history by 4 years. And so Herodotus is placing him cryptically back at Marathon by mentioning this guy with this huge beard. And of course, Xerxes' reason for invading Greece with such a vengeance was because the Athenians had killed his father at Marathon, and that's the reason for his second invasion. There's another reference in passing by Thucydides where he says, indeed it was only shortly before the Persian War and the death of Darius, the successor of Cambyses, etc., showing that there is another reference that suggests that Darius died when the war began. As I said, this is the reason why Xerxes actually invaded with a vengeance the Athenians. He said he wasn't interested in conquering Greece, he only wanted to punish the Athenians, and that makes sense if his father died at Marathon. So how do we coordinate the Peloponnesian War with the death of Darius and the Battle of Marathon? We have to do that in 434 BCE, and that's because the death of Darius in his 6th year has to happen 21 years after Cyrus, and that's the same year the Jewish temple was completed. The Battle of Marathon and the death of Darius that same year is our link to coordinating Greek and Persian history. If the dating of the Peloponnesian War in 403 is correct, then we should come up with 434 BCE. Does it? Of course it does. And here's how. The 10th year of the war occurs in 394 BCE when you date the war beginning in 403, and that ends a 30-year peace agreement. So we can use that 30-year peace agreement to get the correct dating for Xerxes' invasion when that agreement was made. And that brings us back to 424 BCE. That checks out as an Olympic year. There was also an eclipse that year that was mentioned, and so 424 is a very firm year for Xerxes' invasion. And of course, we just add 10 years, and we get 434 for the Battle of Marathon. This means that the Babylonian, Persian, and Greek timelines can be corrected and coordinated using two critical astronomical references now, the VAT 4956 and the eclipses beginning with the Peloponnesian War. And so we can correct the Peloponnesian War date to 403 BCE now. Isn't that great?